going on, everyone? Sneaky Mofo here, and today we're going to hack Doom. We're going to go for infinite health and infinite ammo cheats. And so I'm going to kind of show you some different ways, I guess kind of a process flow for creating these hacks, ways that I like to approach hacking certain games, like this one in particular. So the first thing you want to do is have Doom started up, then attach Cheat Engine to it. And I'm already loaded into a new game here. It's set on Nightmare mode. So here I have these dudes walking around to try to get me. And if there's one thing that can be annoying, it's trying to hack games at their normal speed. You know, sometimes you can crank through it fast, but other times it's nice just to have things go a lot slower. So what you can do is try to enable speed hack. So I'm going to click Enable Speed Hack here, and I'm going to go down to 0.5 and apply. Now when I go back in the game, everything is slower. So this will give me a chance to mess with enemies individually, because in addition to going for infinite health for myself, I want to try to find enemy health. Maybe you can create one-hit kill cheats and stuff like that. So this makes it a lot easier to do those kind of cheats or discover what's in the memory addresses related to doing those kind of things. So the first thing that we're going to do is set our value type to float. You could try 4 bytes first, or you could try searching for all, but in a lot of these newer games, health is a float. So we're just going to go for unknown initial value. Alright, that'll be the first thing that we do. So the enemies are there, so presumably their health is initialized, and so is ours. So we're going to go first scan, and once that's done, we go back in, and let's shoot this one guy. Alright, so we've hit him once, so that's a decreased value. I have hotkeys set up, so I'm going to do decreased value as a hotkey. Search here. Alright, now because I haven't done anything else to that guy, I'm going to do unchanged, scan, unchanged, unchanged. Alright, now we're going to shoot him again and say decreased, then unchanged. So in a situation like this, I'm still doing unchanged. You have to keep up with which enemy is the one that you're messing with to do the scan, you know. Luckily, we have visual cues, like where this guy's missing his arms. Now we know this is the one that we're messing with. So, unchanged value, unchanged. You can do all kinds of other things to keep changing values. Alright, we're going to shoot him again and go decreased, unchanged, unchanged. Now this is about the time you can, you know, we're down to 41 results here. So you start looking for some values that might be values you would expect for health. You know what I mean? Like on a scale of 100 or 200 or something like that. So these 3,000 ones, maybe, but these 290 ones stick out to me above any of the other ones that I'm seeing. And typically you'll see two, because one value will be the actual health value, and the other one will be what the value of health is represented on the screen, which, you know, we don't really see that with the enemies, but it looks like one of these is serving that purpose. So let's go in here and let's shoot this guy again. Alright, so that went down to 70. Now let's try changing one of these. I'm going to change this one to 200. We'll see if the other one changes to something like that whenever we shoot him again to refresh that value. And it did. So, because this one went up to 180, we know that this value we changed is the actual enemy health. So, you know, for the time being, you can say actual health and then fake health. You never know when you might need this address for something as well. So now that we found that, it's a pretty safe assumption these days to assume that health the instruction that writes health is shared between all enemies and even the player or other players. So what you can do is we can right click on this and say find what writes to this address. So that's the first thing that we're going to look for is the instruction writing to that address. So we're going to shoot that dude again. Alright, so there's the instruction that's writing to that address. So the question is, does this very same instruction write to the other enemy addresses and my address, the player address? So what you can do is right click on that and say check if found opcodes also access other addresses. You say yes. Now we can come in here and let's shoot these other dudes real quick. Alright, so we've shot all these guys. Alright. And now I think, let's see, where did that open up at? This new version of Cheat Engine has certain windows that aren't popping up properly. Tell you what I'm going to do instead. I'm going to go show disassembler. This has the breakpoint there. I'm going to go search or view breakpoint list. Remove that software breakpoint because that's what was set. I am going to go ahead and stop this. And now if you right click on the same instruction from here, so this instruction is this, we're just looking at it in the disassembler, right click on it and go find out what addresses this instruction accesses. It's the same thing as what we were trying to do. So there's our box. So now let's go in here and let's shoot these dudes. Alright, so there's 2 addresses. There's 2 more. There's 2 more. Now let me get hit and see what happens. And there we go. So we have quickly identified that that one instruction does seem to be modifying health for multiple, characters, enemies, and the player. Now this game has something funky going on where there's this 0 and then you have the actual health score. Now if you're wondering why these are huge values, it's because everything in this window right now is set to 4 bytes. So if we say float there, now we can see that looks better. So we know that one of these was the one enemy that we shot, so that's that one, right? Alright, this is another enemy, actual health. So now we could do this. I'm going to get rid of that fake health for now. If I was researching, I would kind of keep it, tuck it aside. But we're going to say enemy 1. This one's going to be enemy 2. This one will be enemy 3. This one will be enemy or player. Palier. Alright, so there's health. Presumably. Now you could run around and try to see if that address messes with anything else, or if that instruction messes with anything else. But I'm just going to go ahead and stop that, close it. And now that we know that the same instruction accesses the player and enemies, if we just try to do something with this instruction to say, well, if you see damage, then just don't do anything, that's going to affect everyone. So effectively giving an infinite health cheat using just this instruction itself is going to apply for the enemies as well. So that's whenever you go to Tools, Dissect Data Structures. Alright, we'll do Control G, and we'll say Player. That'll add another group. And this group we'll rename to Enemies. So the first thing that we'll do is back on this where we saw this instruction initially pop up, what we want to do is try to figure out the offset that these addresses are at, right? So whenever you have multiple registers in an offset like this, you just go down here and you see, well, what's in RSI? In RSI we have 0, 0, 0, 0. There's nothing there, okay? Plus RBX, which is this address, plus 1C, offset 1C. So presumably RSI plus RBX is the base, but RSI doesn't have anything in it. So that's pretty curious. But anyway, RBX is likely going to be our base. So we'll take RBX, Control C. You can either put that in exactly, and this was, remember, this was for the first enemy that we were shooting, that first one that we found. So because we have a bunch of addresses, what's better is to just look and see what this offset is, 1C. We know that health sits at 1C away from whatever the base is. So because these are health, we can copy each of these and then go minus 1C, which will show us the base essentially. So Control A, that adds 2 more into the enemies group here. Control C, Control V, minus 1C, Control C, that, minus 1C, and then finally the player, minus 1C. And now you can go structures, define new structure, and we'll call this health. Yes, okay. Now, whenever you specify, when you have everything in one group, the way that it color codes everything when it's similar or different is a certain way. But whenever you add another group, which is when I did Control G, so now I have an enemies group and then I have a player group. And what that'll do is in purple, it'll tell me where values are different between these two groups. So what we're looking to do is identify some trait within these values here and these other addresses that will distinguish the player from enemies. So you go looking through the purple stuff. You avoid pointers. All right, 1C, that's the health. That's our actual health, right? So it looks like maybe this address is max health, and this, or I'm sorry, this offset is max health. This offset is actual health. So right there, that gives you a cue that maybe you want to write a cheat that says, you know, if it's the player, we've identified it's the player, move max health into current health, or something like that, you know. So we have that value there that we could work with. But that's not enough to necessarily distinguish, because if we said, all right, check for enemies, you know, if max health is 150, then do damage. But what happens if we actually get our health up to 150 somehow with like upgrades or something? Then all of a sudden that cheat's not going to work for us, so we keep looking around. This one here looks interesting. So each of the enemies have a 3 here, but we have a 12. So I'm going to work with that offset with a cheat. That's what we're going to work with. So I'm going to still keep that up. Now this is our address here. Actually, let's take a look real quick. Let's see what's going on here in this instruction. Let's go more information, and we want to look in those XMM registers. So XMM 0, 160 was being moved into this dereferenced address. You could try moving other values from other XMM registers, and then you could just do like a declare byte kind of thing instead of an injection. But because we need to write a script that compares enemy stuff with player data, we can't just do like a declare byte kind of thing, which is okay. Alright, so I think what I'm going to do is just NOP if it's the player. I think that's what I'll go for. So you can go Tools, Auto Assemble, Template, AOB Injection. Okay. Let's call this AOB Health. Alright. So now we have our AOB, and what we want to do is we want to have some kind of, let's go label player check, and we're going to, if it's the enemy, we're just going to have it do the normal code as usual if it's the enemy, right? So let's go player check. Alright, Now, at the time that this instruction is reached, what we want to do is we'll copy these things here, and we want to compare. Let's see, it might not let us compile this because I think I have to have this in a specific register, not a memory address. So yeah, the first thing that we're going to have to do is move RSI plus RVX plus 1C. We have to move that into a register. So we're going to use RAX for that. Let's push REX so that we're going to preserve the value that's currently in REX before we start futzing with it here. So then we're going to move the value that's in this address, but not 1C because that's our health. We want offset 30. Offset 30. Okay. So we're going to be moving that value, which is going to be looking at these, into REX. Then we're going to compare REX with, let's see, that's a float of 12. So we're going to say float 12. We're going to compare that. All right. Jump if not equal to code. Right? So when it goes to do this check, if it's not 12, if it's anything other than 12, then it'll just do damage as usual. Otherwise, jump to return. Don't even have to NOP anything. Let's just skip that instruction altogether and see what happens. All right. So we've got code, player check. There's our player check. AOB health. Yep, we should be good to go here. So let's go file. Well, actually, nope. What we want to do is, after we've done our comparison, the flag will be set. Let's pop REX so that we preserved RAX, and here we restore whatever was in REX back into it. So file assigned to current cheat table. All right, we didn't get any warnings. Could be good. All right, so we know this is player and these are the enemies. So I'm going to go ahead and put this back up to 100 because I have this on nightmare mode. So now I'm going to say infinite health. Let's enable it. All right, it enabled. Let's go back in here and see what happens when we get hit. All right, so my health went down to 55. So the script didn't work. Why didn't it work? Well, I can tell you that because remember that 0 thing that was popping up whenever we were finding the other addresses? This RSI messes with stuff. So let's try this. Float 12, we're comparing that with RAX. Alright, that sets the flag. If it's not 12, go to code. If it is, just go to return. Okay, so we should be good. Let's see if this will do it. We say OK. Set this to infinite health. Set this back to 100. Now let's see what happens. Nope, still not working. So why is that not working? Let's disable this. Alright. One thing you can do is check to make sure that the AOB is unique. So we'll go new scan, array of byte, paste it, make sure read and write is selected, first scan. Alright, so that is okay. So we take a look at our script here and we see AOB, it's going to jump to, oh, that's why. I didn't change the jump here. Someone probably already saw this. So the scan runs, right? It goes to AOB health. AOB health plus 7. It jumps to code. So I wasn't even jumping to where I needed to jump first to do the check. So instead of jumping to code, we want to jump to player check. So let's just go ahead and try to keep this RSI here real quick and see if that will work. All right. So it jumps to player check, which goes to here, does its thing, jump to code, return, or just go to return. Okay, we should be good now. Boom. Enable. It's been like a couple of weeks since I've hacked a game, so I'm a little bit rusty here. All right, let me also set my health back up to 100. And let's get hit again. All right. Well, they will hurt each other too, so that one dude died being attacked. And we can see that our player health is looking good. So he just killed his buddy. He's messing with me. Now what happens if we shoot him? His health went down to 60, down to 40, down to 20. All right, so he's almost toast. So that's working as intended. So now, because we also have the enemy health, you know, instead of it going to run the normal code whenever it detects the enemy, instead of moving the normal value into that address, you could say like move 0 for like a one-hit kill condition, right? So that's just how you could do something like that. I think I'm going to wrap it up for now because this one got a little more involved, but it was a good like way to walk through some of this process. Infinite ammo, it's just a 4-byte value scan. It's super easy. You know what, I am going to do one more thing here. Sethios, if you've ever been to his channel, this guy, Pinpoint, I think that's his name. He did a couple of tutorials recently with a topic that I've kind of wanted to cover before, so go check that out. But basically what he does is he shows you how to, instead of having to worry about finding a base address, you just create your own pointer to whatever is currently in memory, and it works every time you load the game. So let's say that we wanted to find the player and the enemy health addresses every time this script runs. All right. What you can do is do global Alex, which will create a label. It'll register a symbol. And this allows you to basically carve out a space in memory that you can reference later, and you can put something there. So we're going to say player health address, and we're going to give it 4 bytes. Actually, let's give it, yeah, 4 bytes should be fine. No, let's give it 8 because we're dealing with 64-bit stuff here. Global alloc player health address, or I'm sorry, that will be enemy health address. Alright, so now what we can do is, once we've established this check here, and we know which address is going to be the player versus the enemy, right? So here we've done this check to see basically, is this health address that's trying to, or is this address that's trying to be written to, is this the player or is it the enemy? So the jump if not equal to code, this is the condition if it's the enemy. However, after the jump, this is what would happen if it's the player. So what we could do is, we could say, I'm not going to worry about being too optimal right now, but we can, we need to move, we know this is the memory address, what's in here. So we're going to go ahead and push REX again. And then we're going to load effective address. This is a way to move a memory address into a register. So instead of moves a value from a memory address to somewhere, load effective address moves the actual address itself. All right, so we want to load into RAX. not offset 30, we want the actual health address, which was 1C. So we're going to put 1C there. All right, and once we've done that, we can then move into player health address RAX. All right, so the value in RAX is going to be that memory address that we can move here into the memory address, or the memory that we have stored here. All right, so then after that, we can put or pop RAX. All right. So now what we can do is take the same thing, and then right before this, or even after it if you wanted, yeah, let's just let the code run first. Then we'll do this, push racks, load effective address, enemy health address instead of player health address, pop, and then there. So now this should be moving the address of enemy and player into our little health addresses that we allocated, some memory for. So I'm going to go OK here. Well, before I do that, I'm going to disable the script. And now I'm going to say OK. Now we can enable the script. And once we do that, we can add address manually. And you want to make it a pointer. And we're going to say enemy health address. And then we say OK. Add address manually. Pointer. Player health address. And we say, well, here, player health. We're going to set it to float. I should have done that for the other one. Okay. Enemy health. Float. Okay. Now let's put these just under the script. Alright, and now we should be able to go in, and when I shoot this enemy, well, he's got 20 health left. Let me give him a little more health here. Let's go 80. Alright, see that 60 that populated right there? Okay, that's pointing to that address. So now let's get hit ourselves. See what happens here. Alright, see the player health loaded right here? So this would be a way for you to always find your way back to that memory address. We didn't find the base address through all the pointers or whatever. We just piggybacked off of the instruction that runs there and said, give us the information wherever that's pointing to right now. That's what we want. So there's a bunch of uses for that. I'll get into all that later. I wasn't even planning on doing any of that for this video, but it was a good time to talk about it. So anyway, give me a thumbs up if you enjoyed the video. If you're not subscribed yet, go ahead and subscribe. Check out my other cheat engine tutorials. I've got a ton of them by now. So anyway, thanks again for watching, and I'll talk to you guys soon. Take care.